So this could just about be your shortest exercise for the year. And it's an enjoyable one. So hopefully it won't take you that long. And I know it's a busy time of the year coming up to the end of the term, so this is a nice catch-up period for you. Right, exponential equations. One method for solving exponential equations is to use the one-to-one property. So if you have a to the x is a to the y, well, because the bases are both equal to each other, that means the indexes must be equal. So therefore, that implies that x equals y. And that's true for all a is an element of the real positives excluding 1. So just the rule or the domain where that a exists if it's an exponential function. So find the value of x for which 4 to the x is equal to 256. So all we're trying to do is get the bases to be equal. So if this is 4 to the x, 256 I think you'll find is a base of 4. So if you go 4 times 4 is 16, times 4 is 64, times 4 is 256. So this is 4 to the 4, and because the bases are equal, that will imply that x is equal to 4. Can't get much easier than that, can it? Sometimes you'll find that you actually have to break the bases down on both sides. Like I could have broken them down and make them both base 2s. The larger the base you can make them, the quicker the answer will be reached. So let's do B. Might even label A, seeing I hadn't labelled A. I'm going to go rainbow pen just for fun. I'm bored. So 3 to the, that's meant to be rainbow pen. Come on, give me rainbow pen. There we go. 3 to the power of x minus 1. It's quite disturbing to have the different colours. 81 is 3 to the 4. So bases are the same. So what does that imply? That the indexes are the same. So x minus 1 must be equal to 4, and then solve for x. So x is equal to 5. Lovely. Does look cool. Okay. When solving exponential equations, you also may need to use some of your index laws. So just running through your index laws, when you multiply with the same base, add the indices. And that goes for the reverse too. When you see it in this a to the x plus y, you can often break them up into a to the x times a to the y. When you divide with the same base, subtract the indices, third one power to a power times. If you've got a bracket raised to a power, both terms are raised to that index, a to the x, b to the x. Onto the second row, when they're divided, raised to a power, both terms get raised to that power. A to the minus x, well, the minus just means 1 over, so 1 over a to the x. Okay. If you do 1 over a to the x, obviously you get a to the x, and anything to the power of 0 is 1. All right, so these last couple of examples. Now, this is the one that always causes the problem. This is a quadratic. Okay, so whether you recognize it straight off, that's the hard bit to do. So when I've got that 9 to the x, well, 9 is 3 squared. So I'm actually going to do it 3 to the 2x. Okay, put everything to the one side, so minus 12 times 3 to the x plus 27 equals 0. So now I'm just going to let 3 to the power of x equal a. So if I do that, then I have a squared minus 12a plus 27 equals 0. So now you can see where it's a quadratic, so we can factorize that. So that's two numbers that multiply to give 27 and add to give minus 12. 9 and 3 look good to me. So a minus 3 and a minus 9 equals 0. a equals 3 or a equals 9. But we're not interested in what a is. We now substitute back for 3 to the x. So a was 3 to the x equals 3, which gives me x equals 1, or 3 to the x equals 9. So x is equal to 2. X is equal to 1 or 2. Beautiful. Second example there. I'll just label that one A. What colour pen will we go for? Purple. This to be different. So we have 3 to the 2x plus, so I'm making it all equal to 0, 6 times 3 to the x, and hopefully you've recognised it's a quadratic, minus 27 equals 0. Okay, so again, let 3 to the x equal a. So we'll have 3 to the 2x is 3 to the x times 3 to the x, so that's a squared, plus 6a minus 27 equals 0. So two numbers that multiply to give negative 27 and add to give 6. 9 and 3 again. So why is this different to the last one? That's the immediate question I ask when I do these, and I guess we will see. So we will have, what are we going to have? We're going to have a plus 9. We want the bigger one to be positive, and because it's a positive 6a, and then you've got a minus 3 equals 0. So a equals negative 9, or a equals 3. So now we have 3 to the x equals negative 9, or 3 to the x equals 3. So in this particular one, what power do you need to raise 3 to get negative 9? And the answer, of course, is that there's no solution, because if you graphed 3 to the x, it's always positive, right? So that's y equals 3 to the x. So that graph is always above y equals 0. So that means that there's no solution. So in this one, there's no solution. And that's why they've given this example, because you don't always get two solutions. So that one's got no solution. 3 to the x is equal to 3. So clearly x is equal to 1. That's how you do those. Right, our little summary. So one method for solving exponential equations without using calculator is to find and express both sides of the equation as powers with the same base. Then equate the indices, okay, as we did before. A to the x equals a to the y. So x equals y. And equations such as 3 to the 2x minus 6 times 3 to the x minus 20 equals 0 can be solved by making the substitution. In this case, substitute y equals 3 to the x. Well, as I said, I do it by letting a equal 3 to the x, and it just makes it easier to see the quadratic, and sometimes you'll even need the quadratic formula to do them. Let's just check out this one little example below, see what that comes to. So you've got 2 to the n minus 4. Now, 8 can be expressed as 2 cubed to the 4 minus n. So remember, our rule is when you raise a power to a power, we times. So now we can say, because the bases are the same, therefore, so should always put that therefore. You can't just say it's equal. We're implying because the bases are the same, therefore the indexes are the same. So n minus 4 is equal to, so when we do that, 3, raise that to the power 3, it's 3 times both those terms. So that will be 12 minus 3n. Move the 3n over here. What are we going to get? 3n and 1n is 4n. Move the 12 over and we'll get 8. No, we won't. We'll get 16. Thanks for picking me up there. Sure one of you did. And 16 divided by 4 is 4. And we are done. So you can now do exercise 5C. And hopefully, or A, B, and C will be done for Monday so that we are all up to date. Enjoy.